is for mu and for p. Population proportion, population mean. This will follow, not today, Wednesday, but this is today. So we're going to look at what it's called confidence intervals for population proportion. And you will see what that means. Of course, it all starts with a point estimate. So this was discussed in chapter 8. So we know that the population proportion has a point estimate p hat. We wrote that a few minutes ago. And now we want to construct and interpret a confidence interval for the population proportion. So first of all, what is a confidence interval? Confidence interval is an interval. Lower, upper. The confidence interval has any confidence interval has a confidence level. The confidence level is 1 minus alpha, and you can say, what is this alpha in a minute? Times 100%. So that's the level of confidence or confidence level. In some books, you'll find it as level of confidence. Confidence level is fine. It's good enough. So what does it represent? Let's say alpha is 0.05, which is a usual alpha. Then what does this represent? 1 minus 0.05 represents 95%. So for a confidence level of 0.05, or if you want, level of confidence is 95%. What does that mean? So 95% of the sample proportions, in 95% of the situations, when I determine the confidence interval, 95% of those confidence intervals, I can repeat the process. Let me say this. I create a sample. I select a simple random sample. I determine the population. I determine the sample proportion. I determine the confidence interval. I determine another sample. I find the confidence interval for that sample, and all of them are 95%. What does that mean? From 100 out of 100, 95 of those intervals are supposed to include the real population proportion. Now, if I choose alpha to be 0.10, then the confidence level becomes 90%. That would be the confidence level. I will create as many as you want, 100. If I create 100 confidence intervals with different samples, 90 of those confidence intervals out of 100, or 90% of them, should include the true population proportion. So this is one way of estimating, but I need the point estimate. So what does a 95% confidence interval represent? I'm going to write it and put it in writing. 95% confidence interval means that 95 out of 100 confidence intervals at the same confidence level or level of confidence and sample size, of course, will include the true, unknown, unknown population proportion or parameter. So that's what the 95% confidence interval. What about 90% confidence interval? It means that 90% out of 100 confidence intervals at the same level of confidence and sample size will include the true unknown population proportion. How do we determine? So how to construct a confidence interval. That's the first thing, and then I'll go through the steps. So a confidence interval will have the point estimate plus or minus the error or the margin of error. What does this mean? For our population proportion, this will be the p hat minus the margin of error is z sub alpha over 2, the square root p hat 1 minus p hat, close the parenthesis, over n, and the same thing with plus. So p hat plus z alpha over 2, the square root of p hat 1 minus p hat divided by n. So we do know how to calculate this. We just calculated a couple of times. We know how to calculate this. We just calculated it a couple of times today. But the question is, what is this? What is this alpha, z alpha over 2? Well, it comes from here. Depending on the level of confidence or the confidence level, depending on what alpha is given to us. For every alpha, we will be able to find a different z alpha over 2. So it depends on the confidence level or level of confidence. Okay. The margin of error basically is this product. So p hat minus the margin of error, p hat plus the margin of error. And here it is. We also have, I put the formula for you in here, and this is the margin of error. Now, I need to go through these steps just to emphasize the level of confidence. As the level of confidence increases, the margin of error will increase. Why? Because this z alpha over 2, as we increase the confidence level, it will increase. We'll calculate it in a minute. So just remember, the higher this alpha, the higher this number will be. Sample size, of course, if the sample size increases, this number decreases, because if I divide by a bigger number, this whole number decreases. The margin of error decreases. The standard deviation of the population, the higher sigma, the wider the confidence interval for a given level of confidence. Okay, so the bigger this, the wider the confidence level, because we subtract more and we add more. Okay, let's see example 2 on page 4. Which page am I on? I'm on 7. Okay. So again, the Gallup organization conducted the poll in such and such with a simple random sample. Nice. So of n equals 1016. And 1,016 Americans aged 18 and older, and they were asked, do you regard the income tax that you will have to pay this year as fair? Of these adults surveyed, 558 said yes. X equals 558. Immediately I have p hat 558 over 1016. I can determine it if you want, or if we are asked to determine it, divided by 1016, and we get 0.5492 or 54.92%. Okay, obtain a point estimate. Done. So the point estimate for population proportion P is P hat 54.92%. Okay. For results based on, we have, for the results based on the total sample of national adults, one can say with 95% confidence, level of confidence, %, fine, that the maximum margin of sampling error is 4 percentage points. So they are told that the margin of error is 0.04 or 4 percentage points. I cannot use that. I have to use a decimal. Determine and interpret the confidence interval for the proportion of Americans aged 18 and older who believe the amount of federal income tax that they have to pay is too high. So this was, it said, it's a different question. It's related, but it's a different question. So do not, maybe I should have put here example 3, not, I don't want you to think that they are connected. It's the same poll, but it's good. So the confidence interval, we are already told the level of confidence is 95%. We are told the margin of error. We don't have to calculate anything other than P hat minus E, comma, P hat plus E. This is the confidence interval. So it's a 95% confidence interval. So the point estimate minus the error and the point estimate plus the error. Okay, no problem. 0.5492 minus 0.04 and 0.5492 plus 0.04. So when I subtract, I get 0.5092, and when I add, I get 0.5892. That was painless, so we didn't have to do anything. Okay, so now, what is the interpretation? From 100 samples, 95%, 95 of them will include the true population P, true proportion, which I don't have. If I repeat this experiment, if I do this with another sample of 1016, and I repeat and I repeat and I create 100 samples, and I create 100 confidence intervals of 95% with the same sample of size, but they will all be different. At least 95 of these intervals will include the true population proportion. Potentially, 5 of them will not. Any questions on this? Any questions? Good. Next example. In the Parent-Teen Cell Phone Survey conducted by Princeton Survey Research Associates International, 800 randomly sampled of 16 to 17-year-olds living in the United States were asked whether they have ever used their cell phone to text while driving. So the sample size is 800. Of the 800 teenagers surveyed, 272, X equals 272, indicated that they text while driving. Obtain a 95% confidence interval for the proportion of 16 to 17-year-olds who text while driving. Okay. First by hand, then with a calculator, and then with Statcrunch. And yes, I know you're never going to do it by hand again, but the problems may ask you, determine this, determine that. So a 95% confidence interval will be p hat minus z sub alpha over 2, the square root of p hat 1 minus p hat divided by n, and the same thing with plus. P hat plus z sub alpha over 2, the square root of p hat 1 minus p hat over n. P hat is a piece of cake, is 272 over 800. The square root and everything else can be determined, but I want to focus on alpha over 2 and how we determine this number. This is a very important number. Okay, so since we are talking about z, what kind of distribution has z scores? Can anyone tell us the distribution for z? Anyone? Distribution for z. Please. Anyone? Anyone? Distribution for z.
I'll guess 100.
That was cute, Emma. I would normally give you a hug, but I just accept virtual hugs. That's the only kind I can give these days. Know that z is a normal distribution with mean 0 and standard deviation 1. Please remember, everyone. So 0 is right in the middle, and we're talking about 95%. Okay, so here is 95%. If that's the case, these two tails, can anyone give us the area in the tails or the percent in the tails?
Each or combined?
Combined will be 5, yes, and each will be very good. Very good question, Sean. You corrected me, and you're correct. Good. So this is our z alpha over 2. Well, it's the negative one because it's to the left of 0. And this is our z alpha over 2. And it will be positive because it's to the right of 0. So then this area is 0.025. In order to determine these two numbers that have to go in here, I go to inv norm, the area to the left, 0.025, mean 0, standard deviation 1. I guess it's in this calculator normally appears with 0, 1. It's the left, yes. Give me the number. Ready? And we have to memorize it. I think it's useful if we memorize it as negative 1.96. So this will be negative 1.96. Of course, this is 1.96. We don't change signs here. Both these two are 1.96 and 1.96. And I find the confidence interval now. So 95 confidence interval for P is 272 over 800 minus 1.96, the square root of 272.800 divided by 100, 1 minus 272 over 800, divided again by 800. I didn't want to calculate. We can. And the other one will be 272 over 800, but plus, same thing, 1.96. The square root, I'm going to write same. Of course, there is a very easy way out. And here it is. We go to stats, go all the way to tests, and go up to one proportion z interval. It's item A, one proportion z interval. Press enter. X is 272. N is 800. Confidence level is 0.95. You just have to press 3 buttons. And here it is. So if we repeat the experiment 100 times, 95% of all these intervals have to contain what we don't have, the true population proportion that I do not have. So a 95% confidence interval is 0.3072, 0.3728. Let's look at Statcrunch. Ready? I'm sharing. So we go to stats, proportion stats, one sample with summary. So go to stats, proportion stats, one sample with summary. Fine. Number of successes. Where is my keyboard? Okay. Number of successes is 272. Number of observations, 800. No, we do not do hypothesis testing yet. It will come up very soon. We want the level of 95%. Yes. That's it. Confidence interval plot. Why not? Compute. Okay, let's see what we get. Sorry, guys, I have to move you. So 0.3072 and 0.3728. And when I go to this, what is this? No, it's not what I thought. I thought it would graph the normal. Okay, this is it. So the proportion, the sample proportion is 0.34. I was lazy. I didn't want to divide it. 272 by 800. The standard error, this is the standard error that I didn't calculate, the square root. Okay? And the lower limit of the interval, the upper limit of the interval. Any questions? Good. Where was I? Here. No, where was I? Okay, so yeah, we are on page 5. Yes, that's correct. Let me move my keyboard away. Any questions? Final item for today. Determine the sample size necessary for estimating the population proportion within a specific margin of error. Okay. So, given alpha and E, find sample size N. Okay. So we do have this formula so far, Z alpha over 2 and the square root of P hat 1 minus P hat divided by N. You do not have to do this, but I want to show you where it's coming from. I don't want to just give you the formula and say, hey, this is it, let's use it. So bear with me for 1 minute. I want to show you how we get this.